you are getting more and more exposed to inclined planes, and in a certain sense getting more accomplished with the idea of drawing free body diagrams, resolving forces, writing equations of motion in directions that make sense. That'll make the algebra easy. In context of that, here I have another problem just for you, and this problem is about these two fixed inclined planes making an angle alpha each with the horizontal. There is a cylinder of mass m1, there is a cylinder of mass m1, and it is touching a wedge vertically. This is a wedge whose this surface is vertical and of mass m2. Now, assuming that m1 and m2 maintain contact, we want to be able to find the normal force exerted by the wedge on the cylinder and the cylinder on the wedge. That means, the normal forces that they exert on each other. M2 will exert a normal force on this N in this direction. The cylinder will exert on the wedge a normal force N in this direction, right? Which is of course horizontal, as you can see, because this surface is vertical. And this N, its line of action will pass through the center of the cylinder, right? Now, how do we do this? So, it's about, resolving appropriately. Look at the wedge side of the story. What are the forces acting on the wedge? That is this. Of course, the cylinder exerts on the wedge a horizontal force N like this. There is weight m2g acting downwards, the wedge, and then this inclined plane will exert on the wedge. This inclined plane will exert on the wedge a normal reaction N1 like this, right? This is the summary of forces. What about the sphere? Look, the cylinder will exert on this, not the sphere, but the cylinder. The wedge will exert on the cylinder a normal force N that will pass through its center. Weight m1g acting downwards, and normal reaction N2 from the inclined plane making an angle alpha with the vertical, which you see more clearly here. Weight acting downwards, N horizontal, and N2 making an angle alpha with the vertical direction. This is how it is, right? Now, surely, along the common normal direction, this is the common normal direction for the wedge and for the cylinder. This is the common normal direction. Both must enjoy the same acceleration A. Both must enjoy the same acceleration A, right? Now, if you think about the wedge, mass m2, what are the forces that will cause the wedge to have an acceleration in this direction? Okay, there is n1 sine alpha, as you can see, component of n1 in this direction, n1 sine alpha minus n, that must be equal to m2 into A, right? Right? And for this, what causes the acceleration A? Okay, here we have n, and minus n2 sine alpha equals m1a, So let me call this equation 1, let me call this equation 2. Now, of course, from these two, I can eliminate A because A is not what I'm seeking. So to eliminate A, I have like a n1 sine alpha minus n divided by m2 equals n minus n2 sine alpha divided by m1, right? By eliminating it, this by m2 is this by m1, each is equal to A, right? Now, I also need to eliminate n1 and n2. So what I do here is to eliminate n1 and n2, realize that, look at the wedge side of the story. It remains in contact with this inclined plane, and this inclined plane is fixed. So in this direction, the net of all forces acting on this wedge in this direction must be 0, which means what? Look, this angle is alpha. Very clearly, n1 in this direction must take care of, n1 in this direction must take care of m2g cos alpha m2g cos alpha plus n sine alpha. Component of n in this direction is n sine alpha, right? That's as far as this is concerned. Now, what about n2? Look at this n2. How do I eliminate n2? See, again, in this direction, the cylinder is maintaining contact with the inclined plane. That means net of all forces in this direction is 0. Because the inclined plane has no acceleration in this direction, so the cylinder should also not have an acceleration in this direction. That means what we have is n2 being balanced by m1g cos alpha plus n1 sin alpha. See, n2 being balanced by component of m1g in this direction. This is m1g cos alpha plus n sin alpha, right? So we have n2 being equal to m1g cos alpha plus n sin alpha, right? Now what I do is, from the n1 and n2 that I have obtained from here, I can plug into these equations and solve for n. So let me just do that. This is by m2 and this is by n1, I guess. This is by m1. See, this divided by m2 is this divided by m1. Each is equal to a, of course, as you can see, right? Now n1 I plug into this, and of course, you know what I do is I could multiply this by m1 cross multiplying and this by m2. This is what I'll do. Right? And then I substitute the values of n1 and n2 from these two equations, right? So then I have m1 into n1 sin alpha. N1 sin alpha means this into sin alpha, which is like a m2g cos alpha plus n sin alpha into sin alpha, right? n1 sin alpha is this minus n, right? That's equal to n minus, that is m2 into n minus n2, which is this into sin alpha, m1g cos alpha plus n sin alpha into sin alpha. This is what I have. I hope you realize what I did here. The n1 source from here, the n2 source from here. N2 is this m1g cos alpha plus n sin alpha into sin alpha. This is what I get, right? Now, how do I solve for n? Again, notice that right from this equation, I have m1 m2g cos alpha, m1 m2g cos alpha, and then n sin square alpha minus 1 is minus n cos square alpha. Please check that out. Sin square alpha minus 1 is minus cos square alpha. So minus cos square alpha into m1 equals m2 into n into 1 minus sin square alpha, which would be n cos square alpha again. Cos square alpha. And then, of course, I have minus m1g cos alpha sin alpha. So minus m1g cos alpha sin alpha. Right? This is what I have. Okay. Now let me just perform the last rites on this. These two terms I club together. I take n cos square alpha common. So I take n cos square alpha common, transposing into m1 plus m2. Of course, I have already used this m1 here, so okay, that's all right. m2g cos alpha, and then of course m1 m2g cos alpha and m1 m2g cos alpha sin alpha. Of course, there is a sin alpha also here. There is m2g cos alpha sin alpha. I'm sorry, I'm goofing up a little bit. Cos alpha sin alpha. Fix the algebra. I hope you realize what I did. This is m2g cos alpha sin alpha whole into m1, right? And there is m2g cos alpha sin alpha into m1, and there is m1 m1g m2g cos alpha sin alpha. I can transpose on one side, and I end up getting 2 m1 m2g sine alpha cos alpha is what I get, right? And then 1 cos alpha will get cancelled with 1 cos alpha, and then I end up getting n equal to 2 m1 m2g sine alpha by cos alpha tan alpha, sine alpha by cos alpha tan alpha by m1 plus m2. Right? I know the algebra was a little ugly, but nevertheless it made sense to go through the very end of the problem and come to the desired conclusion. So n is, as you can see, 2 m1 m2g tan alpha by m1 plus m2. I hope you realize what I did here. This n cos square alpha taken common, m1 plus m2. And there is m1 m2g sine alpha cos alpha. There is m1 m2g sine alpha cos alpha transposed on this side. That'll make it 2 m1 m2g sine alpha cos alpha. 1 cos alpha gets cancelled, and then we have n equal to 2 m1 m2g divided by m1 plus m2 into tan alpha. That's what happens here, right? All good. So I hope you're beginning to breed more and more familiarity, even if it involves a little bit of an ugly algebra, but the ideas are the same. There are no new novel ideas that we have used here. You use plain simple notions to arrive at simple conclusions, sometimes with easier algebra, sometimes with a little more messier algebra, but I hope you are getting comfortable, you are getting there, you are coming to terms with the basic idea, the basic philosophy, and the underlying principles. Thank you so much. Bye-bye.